Assalamu alaikum students. Today we shall complete the mass spectrometry topic which we had started yesterday. So as we were discussing, how do we find out the actual structure of the molecule by interpreting these mass spectra? So here in this question we are provided the molecular mass which is C3H8O. Now, on this basis, we have to determine which would be the alcohol. And I told you in our previous class that it could be one of these two, the propanol, which could belong to this mass spectra, and propanol, which could be matching with the second or any one of these two. So we have to identify. For this purpose, we need to draw the displayed formula of these two compounds separately, and then we have to apply the principle of fragmentation to identify the right structure. So propanol is like this, and we have hydrogen atoms on all these carbon atoms, and propanol is a structure like this with the hydrogen atoms. Now we have to do the fragmentation. So I will do the fragmentation first from here. Now it will give me methyl group on one side and CH3, CH2, CH2OH on the right side. So I got two fragments from here. The CH3 fragment, methyl cation, and then CH2, CH2OH cation. Now over here, I will do fragmentation over here. This will also give me CH3 cation, and the other part will become CH3 CHOH fragment. Now we need to find out the values of their masses to identify which of the peaks are matching them. This CH3 is already calculated to be 15. Now I need to find for this. It is equivalent to 24 plus 5 plus 16. This gives me 45. The value of this fragment is 45. And then for this fragment, it is again 24 plus 5 plus 16. Now this is also 45. On this basis, we cannot differentiate which of these two is a alcohol of these two parts, because both of these alcohols are providing the same fragment. So we cannot reduce from here. However, we can now try to find the fragment from any other portion. Now I will fragment this molecule from here. This will provide me CH3, CH2, which is ethyl cation, and the other part will become CH2OH. Now the value of this ethyl cation is equal to 29, m by z value, and the cation of this fragment will give me value of 31. Now for this one, I will do the fragmentation from this and this side, both of these sides. Although it will provide me two methyl cations, but they are no use for me because both of these molecules contain the 15 value, so it is of no use. However, this part is a different fragment here. So let's check how does it give. It will make fragment CHOH cation. This fragment has CHOH and the value of this part becomes 30. Now from here we can see that one of the peak over here, the above spectrum, जो ऊपर वाला spectrum है, इसके अंदर value जो आई थी वो 31 fragment की है. So this 31 fragment is the one which came from the propanol. So we can see from here that propanol has this peak. This peak belongs to propanol. The 15 value in both of them were already checked, so we cannot differentiate them. However, this part is giving us the spectrum at giving the peak at 45. So a peak of 45 is here. 45 is present here. So 45 was already produced in both of the spectrum, so we could not identify which spectrum was belonging to which alcohol, but on the basis of this peak of 31, which is not being given by the propan-2-ol, we can say that this is the peak of propan-1-ol. This peak belongs to propan-1-ol. And the second peak will be definitely belonging to the propan-2-ol because that is not giving a peak at 31. So all of the information is provided here. So you can read the passage and you will get to know that how did we match the mass spectra here. Now another example is of propan-1-ol. Same compound is given here. Propan-1-ol. In previous case, we deduced by ourselves, but in this case, the fragments are already given. You can see from here that this is a compound structure, propan-1-ol, and this compound is now fragmented at different parts. The complete mass M by Z value is given 60. Now, if we do the fragmentation by removing one hydrogen, then you will get this fragment. Value is 59. So 59 value is checked here. This is 59. Then if we do further fragmentation from here, from this part, the fragmentation is done CH2OH, which means it has cleaved from this point to make CH2OH, and the other part becomes ethyl radical. Now CH2OH value is 31. So 31 value is given here. That is of the highest value. We also checked that 31 value in our first spectrum over here when we said this is CH2OH value, which is of very high intensity. Abundance is of 31 is the highest. So we can also say that this 31 is the base peak having a highest intensity. Now further fragmentation of this compound ethanol over here, it is now clear from this point. Now when it is clear from this point, you will get C3H6 from here. It is now they have instead cleaved the point from here. One hydrogen is cleaved from this carbon and the OH is cleaved from this point, one hydrogen and a water. So this will give you C3H6, which is 42. Basically, this is how they have cleaved. They cleave one from here and another bond from here. What we deduced in our previous in the start that we can cleave bonding from any particular point. So they have cleaved from 2 points, from the OH point and then from one of the hydrogens at the terminal carbon. So that's how you get C3H6. And this is already understood. C2H5 is basically the ethyl cation. In this case, it was the radical, but here it is a cation. The value is 29. So you can match these fragments with these particular values. Now this mass spectrum is of the butanone. So which means you are supposed to find some fragmentation values from here as well. And this is kind of a practice. The butanone is like 4 carbon atoms. And then you should know the functional group of ester, since butanone is basically the ketone. So you're supposed to find the functional group of ketone. Now you have to do the fragmentation for this ketone. Okay, so here fragmentation, when done from this point, you will get methyl from this side and then 3 carbon atoms, C3, 3, 4, 3, 5 hydrogen atoms, C3H5, and then 1 oxygen atom. So if you calculate the mass of this point, it will be 36 plus 5 plus 16. It is equal to 57. Now, this is a peak which is belonging to the 57 over here. If we cleave from, and then this point is already produced, methyl radical, methyl cation. And if we cleave from this point, you will get ethyl cation. This point, this side become ethyl. So this is ethyl cation over here, C2H5. And the other part is CH3CO, CH3CO. Now it is equivalent to 43. Now this fragment is mentioned here, and this is a base peak because its intensity is highest. So in the same way, we have already checked this 15, we have checked 29, we have checked 43, and you can in fact also produce fragment. If we cleave from here, it will produce CH3, CH2, CO. So you can keep doing fragmentations, and then you will come to know that which fragment is belonging to which value. So the rest of the peaks are kind of your assignment, which you can do in your later time. So we already checked the mass spectrometry of the butane here for pentane. Now this graph, it is of the ethanol here. So some peaks are shown here for ethanol, and you can find which fragment is being produced by cleaving at different points. So you have the peak for OH, peak for CH3, peak for CH2, peak for CH2OH, and same way. So these are different peaks, and for which the cleavage are done in the case of the ethanol. These are the fragmentations of an alkane compound. So if you have large size alkane compound, then you can cleave from different carbon atoms, and you will get these different fragments of individual of separate intensities. They are matching with this table. It has 6 carbon 6, and over here they are 8 carbon atoms. So which means the compound is broken down at different points for a large size of the alkane chain, and that's how you get different fragments. Now this is of the ethanol again. Another graph is provided here. You can match this graph with the ethanol graph or ethanol spectrum over here. So you will find similar values in both of these spectra, this ethanol spectra and this ethanol spectra. Now over here we have again the ethanol along with the representation of the M+1 peak. So these are also the ethanol spectra. Over here they are showing the values. Over here they are showing the fragments. And that's also showing the fragments, so you can compare which point is produced by fragmenting the ethanol molecule. Now for this one, that's a mass spectra of the propanal, and propanal is an example of the aldehyde. So here's a different example. You can do the cleavage from here. You can see on one side, when it is cleaved from this point, it will produce the CH3 CH2 cation, and the other part will become CHO cation. Their values are mentioned 29 and 29 each. So you get a very high intensity of this 29 value. And when it is cleaved from this point, you will get CH3 CH2CO. This is that fragment along with the hydrogen. But hydrogen fragment is not shown in the mass spectrum, whereas the other fragment is shown here. And later on, this fragment is further converted into CH2 by removing one hydrogen, and this fragment is not further broken down, and this CH2 is further broken into CH2CH, further broken down into CH. So that's how you see 28, 27, 26 peak values over here, but they are not indicated by their values. They are just indicated by their peaks, which means these would be the not useful, unnecessary peaks for uh, our identification of the compound. Now this is the example of the ester. So methyl methanoate. For this compound, the fragmentation is done here, and you have to match the mass spectrum with that of the fragmentation. So it is fragmented from this point to make HCO. The value is 29, and you get CH3O on the other side, so 31. 29 and 31, these are represented here. And after, on the other side, when it is cleaved from this point, you get methyl cation, and the other becomes HC double two oxygen atoms. The M by E value is 45, but it is not indicated in the mass spectrum, which means it is of not a good stability, or maybe because absent because it does not form the ion. So it could be also a reason that it is basically a radical. It is not the cation, instead it is a radical. It would not be having ability to make ion. That's why it is not shown here in the mass spectrum. That's the mass spectrum of the carboxylic acid. So you can see how the different parts are cleaved here to get different fragments. And this is the mass spectrum matching with this carboxylic acid. This is again carboxylic acid, it is the ethanoic acid, and this is the mass spectrum of ethanoic acid. Now the next is There is a topic to check how many carbon atoms are present within the organic compound by considering the carbon 13 isotope. And this topic is very important since this formula is mentioned multiple times in the past papers. In this formula, you are supposed to find how many carbon atoms are there in the molecule, and the formula to find that number of carbon atoms is n is equal to 100 into abundance of the m plus 1 cation. This is m plus 1 cation divided by 1.1 into abundance of m plus ion, which is a molecular ion. So in denominator, we will write the value or the abundance of the molecular ion, and in the numerator, you will write the abundance of the m plus 1 cation. So here's an example. The question says you are given m plus peak of a compound which has a value of 136 with a relative abundance of 17% and an m plus 1 peak at m by e 137 where the relative abundance is 1.5%. So here you can see that molecular ion peak has 17% and the m plus 1 peak abundance is 137. The value is 137, which indicates that this is the abundance of the m plus 1. So its value is 1.5%. So just by applying this formula and putting the values of the m plus 1 peak and then molecular ion peak. So 1.5 is the abundance. Abundance is taken in the percentage values in the question. So you will write simply the value, not the percentage. You will not write the percentage symbol here. And for the molecular ion, the percentage is 17. So after doing the calculation, the value comes out to be 8.02. You have to round off this value into the nearest whole number because the number of carbon atoms are supposed to be in whole numbers. Since this formula is used to find the number of carbon atoms, so it cannot be in fraction. It could be only in whole numbers. So when it is rounded off to nearest whole number, it gives 8. Now the next topic is the M+2 and M+4 peaks. Now basically in this topic we are supposed to consider some organic compounds, especially the halogen alkane compounds, in which one or two hydrogen atoms will be replaced by the chlorine atoms. Now chlorine atoms are now discussed in terms of the isotopes. You know that chlorine atoms have two isotopes, chlorine 35 and chlorine 37. The chlorine 35 is present by 75% and chlorine 37 is present by 25%. Now these are the isotopes. Now if we consider that we have an organic compound in which there will be a presence of the chlorine 35 only, then this will produce a simple molecular ion peak. So let's suppose it says a compound 2-chloropropane. There are 3 carbon atoms, and on carbon number 2, we have the chlorine element of isotope 35, which is present by 75%. So this is an isotope 35. This will produce the molecular ion peak at this value. But if we do not have chlorine 35, instead we have an isotope of chlorine 37. When I will write chlorine 37 over here, then this time the value will be increased by a unit of 2 because chlorine 35 and chlorine 37 have a difference of 2. So that increased value of 2 will give a peak at M plus 2 cation peak. So M plus 2 peak is provided by chlorine 37. When in the molecule we have only one chlorine atom, and that only chlorine atom is an isotope of 37 that will produce a peak at M plus 2. So that's how we say M plus 2 peak is present there. So here's a uh, the formula of the 2-chloropropane in the cationic form. If molecules contain chlorine 35, the M plus peak will be at 78. So you can see from this mass spectrum, the value at 78 belonging to the chlorine 35. But if the molecules contain chlorine 37, then the M plus 2 cation peak will be at M by E value of 80 because it is of increment of 2. But there will be a difference in their height, or you can say a difference in their intensities. The M+2 peak will be present by 1/3 the height of the molecular ion peak. It is of 1/3. Why is it of 1/3? Because you can see from here, chlorine 35 is of 75% and that is of 25%. And if you take simply take their division, 75 divided by 25 will give you 3. So 3:1, which means the abundance of 35, the ratio of 25% will be of 1, and the uh, intensity or abundance of the 75% will be a ratio of 3. That's why they are saying that 3:1 height are seen in their mass spectrum. You can simply also check in this graph as well, in this mass spectrum as well. Now, uh, this time they have included 2 chlorine atoms. A summary of this chlorine can be seen from here. So if we have a compound containing 1 chlorine atom, then a peak at an intensity of 3 ratio will be of chlorine 35, and if there is an isotope of chlorine 37, then the peak height will be at ratio of 1. So 3:1 is seen between chlorine 35 and chlorine 37. These This is an example in which the compounds contain only one chlorine atom. Only one chlorine atom. Now we look for a compound in which there are 2 chlorine atoms in a molecule. So for this case, we will now consider an example of the 1,2-dichloropropane. So 1,2-dichloropropane is an example. Now in this case, I will write a small simple structure. We have 3 carbon atoms and then we have 2 chlorine atoms on them. One chlorine atom over here and another chlorine atom over here. But I'm going to make some combinations. If I write that both of them are chlorine 35 each, then you will simply compute their M by Z value, their mass value, which will come out to be 116. Sorry, that value is 112. The value for this whole molecule in which you will complete the hydrogen atoms as well, and both the chlorine atoms are of the chlorine 35 each, then the mass will become 112. But if I change one chlorine 35 with chlorine 37, now there is a difference of 2. The value has been increased by 2. So this time the M by Z value or M by E value become 114. Now if I substitute the other 35 with another 37, it will give me the M mass value at 116. So these are the 3 values which are representing 3 combinations of the chlorine 37, chlorine 35 chlorine 37 and chlorine 35 and 37. Which means if I write here chlorine 35, 35, chlorine 35, 37, and chlorine 37 and 37. That's how I'm getting the values over here, and these values are basically belonging to the 1,2-dichloropropane, not just chlorine atom but the whole molecule. Now what about their intensities? You know that for intensity of chlorine 35 is 3 ratio because it is present by 75%. It is 75% chlorine 35, whereas chlorine 37 is present by 25%. So it is a 1 ratio. It becomes 3 ratio, and this becomes 1 ratio. Now, how do we find 961 here? These are basically their ratios. Let's suppose if I'm taking chlorine 35, 35 both, then it will be like 3 ratio into 3 ratio. That gives me 9. Both of these 35 are present, so to find out the overall value, I have to multiply them. So 35 ratio is 3, 35 ratio is 3, so 3 times 3, 9. Now 35, I will write for 37. 37 is basically 1 ratio. So I will write 1 into 1. That gives me 1. So that's how I get 1 here. Now what about 6? How is 6 there? You know that chlorine 35 and 37 both are present in that case, but it is not like that. It is basically 35, 37. In one case, the first chlorine was of 35, the other was of 37. In the other case, the first chlorine was of 37 and the other chlorine was of 35. So that's how it is shown. 35 ratio is basically 3 and 37 ratio is 1. So 3 into 1 gives me 3. And the other case is also the same. For 37, I will write 1, and for 35, I will write 3. So again, value is 3. But now I will add both of these values. It will give me 6. So combination of 35 37 is 3 into 1 in terms of their ratios, and combination of 37 to 35 will give me value of 1 into 3. This is ratio 1 for 37, and this is ratio 3 for 35. Now 3 into 1 gives me 3, 1 into 3 gives me 3. Now I will add these two together, it will give me 6. So that's how this 6 is mentioned in this mass spectrum. Now here you can see the M plus peak is belonging to the compound containing both of the chlorine 35. The M plus 2 peak is provided when one of the isotope is of 37 and the other is 35. And the M plus 4 peak, now that's a new thing here. How do we get M plus 4 cation? M plus 4 cation is provided when both of the isotopes are of 37. They are basically compared with that of the chlorine 35, 35. So you know that chlorine 35, chlorine 35 plus 35 give a value of 70. Chlorine 35 plus 37 give a value of 72. Chlorine 37 plus 37 will give a value of 1114. So if you check from here, this will become molecular ion peak. This will become M plus 2 cation, and this will become M plus 4 cation. And in terms of the ratios, this is a ratio of 9. This is a ratio of 6 by combining two combinations. And this is a ratio of 1. So 1, 9 ratio 6 ratio 1. So you will find the intensities as well here. So this one is showing a molecule of chlorobenzene. Chlorobenzene has only one chlorine atom here. So that's why we find only one chlorine atom here. The value is 1112 for here. And there's a M plus 1 peak over here. Now M plus 1 peak at a value of now you will have you have now two phenomena occurring at the same time. The phenomena of the M plus 1 and the phenomena of M plus 2 in M plus 3. Now what does it mean, M plus 3? Basically, the compound contains only one chlorine atom. So basically, you will have only one isotope That could be chlorine 35 or chlorine 37. If it is chlorine 37, then the peak will be of M+2 definitely. So it will produce M+2 peak. But within that, if you add an isotope of carbon to be 13 instead of 12, it will give you M+1 peak. So combine these two together, M+1 peak from the carbon 13 and M+2 peak from the chlorine 37, it will produce M+3 peak. Now that's another thing here. Although it is not mentioned in the syllabus, but that's one such example here that it could be produced. You will need to take into account both the isotopes, the isotope of the carbon and the isotope of the chlorine. Now, another type of the combination which we can find is in case of the bromine. So bromine, again, it will produce haloalkane compound. Now, there are two isotopes of bromine which are mentioned in your syllabus. We have bromine 79 and bromine 81. And by fortunate, they are both of almost similar intensities. 50.5%, 49.5%. They are almost of the same size or same intensity or same abundance in nature. So what you will have here, you will see that when a spectrum is given for such a compound in which there is a presence of only one bromine atom. So for one bromine atom, the peak for M plus peak and M+2 peak, they will be almost of the same intensities. M plus will be the one when you will have the 79, and M+2 will be the one when you will have a bromine of 81. So bromine 81 in this case and bromine 79 in this case because of the difference of a 2. However, the intensities will be almost similar. You will not find such a difference in them in terms of the intensities. So that's the thing. You will need to distinguish the peaks on the basis of chlorine and bromine. The chlorine have clear cut difference of 75% and 25%, which means their intensities or their peaks are of the order of 3:1. Whereas in case of bromine, their intensities are almost similar and their isotopes are also of difference of 2, but the intensities are of same, which means you will be able to distinguish that this mass spectrum is belonging to a compound containing bromine atom or containing the chlorine atom. Now we'll take another example in which there will be presence of two bromine atoms. So let's suppose if we have a compound if we have a compound containing two bromine atoms, then in this case, that's how you will find the peaks. If both bromine atoms are of 79 isotope, then the value of this whole compound will come at M by E value 186. When one bromine is 79, other is 81, you will have value at 188. And if you change them, this become 81, this becomes 79, you have again 188. Whereas if both of these isotopes are of 81 each, you will get a peak at 190. Now, they are also represented in terms of the type of peak. This belongs M plus peak. This is molecular ion peak. This is M+2 peak. This is M+2 cation peak. And this is M+4 cation peak. Now, this M+4 is produced when we had two bromine atoms. Just like we had in case of chlorine when we supposed that two chlorine atoms of 37 isotope were present in a molecule. If both of the chlorine atoms of 37, we got M+4 peak. In the same way, we have M+4 peak when we have two bromine atoms in a molecule. Now, what about their ratios? So you know that both bromine atoms are 1:1 because of their equal intensities. So I will write 1 for 79 and 1 for other 79. It gives me 1. Now for 79 into 81, again, it will give me 1 into 1 equal to 1. 81 79 gives me 1 into 1 is equal to 1. And 81 into 81, ratios of 81 to 81 gives me 1 into 1, again 1. But these two are basically such a combination in which we are showing two isotopes, two different isotopes. 79 and 81, both isotopes are indicated here, which means we need to add these two values. Just like in case of chlorine, we did the same in chlorine. So this will give me 2. So that's how we get a ratio of 1:2:1. That's the ratio when we have two bromine atoms in a compound. If we compare with the chlorine, we had 9:6:1 in case of the chlorine molecule containing two chlorine atoms. So that's what you will see here in this graph as well. Now the summary over here is mentioned. We have a molecule containing two bromine atoms. So molecule containing one bromine atom. So the intensities are same. 79 and 81 both have the same intensity, but the value is has a difference of 2. That's what we already discussed. When a molecule contains two chlorine atoms, then the ratio will be 9:6:1. And this belongs to molecular ion peak. This is M+2 peak. This is M+4 peak. Now for bromine, if we have a compound containing only one bromine atom, the intensity will be the same and the difference will be of 2. So M+2 peak here, M plus peak 1, and this is 1 ratio. 1 stand for ratio. This is a ratio of 1. This is also a ratio of 1. And we have compound containing two bromine atoms. Then again, as I told you, we can have two combinations here, 79:81 and 81:79 combination. So that's why the ratio is 2. But the difference is of M+2 because we have 181 isotope here. So that's the mass spectrum of a compound, such compound. Now this topic of mass spectrometry is finished here, and we have now officially completed the whole of the AS organic AS organic. We have completed the whole AS chemistry. So I hope that has been very beneficial for all the students. So now we'll start with the past paper practice in our next class. Till then, take care and Allah Hafiz, students.